too much room on your table, then you probably don't want it on your table because you are crunched for space anyway, okay? So, two things that I have up here on my announcement board that's on the slides. There is no school on Friday, okay? Everybody has off on Friday. So, you do not have to come on Friday. Thank goodness, your first full 5 days face-to-face is actually a 4 days face-to-face week, okay? So you don't have to come on Friday. You get a day off to recoup from the fact that you've been 4 days on a 5-day week. Yay, right? Then we have 2 full weeks, and you will be on spring break for the first full week in April. So if you have not been looking at the calendar, you have been looking at the school calendar, then you might want to take note of those days. Make sure you enjoy your spring break because that's your last day off until the end of May. Okay? You won't get another day off till the very end of May. So, enjoy it. Okay? In your table of contents, I want you to add today's date, which is the 16th, and I want you to add 6-2 Outliers. I think that we're on page 30. Are we on page 38? 38 today? 39. Let me look, because I messed up my numbers yesterday. Give me 1 second. I think we are on page 39. Give me just 1 second. Sorry, Ari, I didn't mean for it to be thrown at you. Let's see. We are on page 39. I'm very sorry. That's my fault. Let's see. I'll fix it. $37, $38, $39. 37, 38, 39. So today's lesson is on page 39. So I do want to talk to you a little bit about our indicator today. It's different from the one that we did yesterday. I have 2 indicators up here. The first one is describe numerical data sets in relation to their real world context. Okay, so I want you to stop what you're doing for just a second. Everybody stop. Stop taping, stop moving, start listening. Okay, remember, none of this matters if you can't apply it to the real world, okay? So, we are going to look at real sets of data to see if there's something that sticks out, okay? Something that doesn't make sense, all right? And we have to be able to tell the impact of a number that just doesn't fit, if it's in the data or if it's been taken out. Now, let me show you something. Take dispensers. There's only 1, maybe 2 at each table, so you have to share. Watch what I do, because y'all are tearing a piece, then taping, then tearing a piece, then taping. We don't have time for that. You need to take and tear off 4 pieces, put it on your table for your taping, and then pass the tape dispenser to someone else at your table, okay? You do not have time to tear a piece of tape, tear a piece of tape, tear a piece of tape. Just tear off 4 and pass it, okay? You only have enough, unless you have your own tape, okay? Then you need to be tearing and passing, all right? So, I did put this at the top of your notes page. I can describe how an outlier affects measures of center for a data set. So we're going to talk about what an outlier is, and we're going to talk about how it affects measures of center. Okay? So who can tell me what measures of center are? We talked about them yesterday. What are measures of center? We talked about 3 yesterday. What were they? Mean, median, and mode. The 3 M's. The 3 M's are the 3 measures of center that we talked about yesterday. All right, how many people have a highlighter? Take it out. If you don't, get the one out of your caddy. There should be one in your caddy. And I want you to highlight the word outlier. All right, then I want you to put your pencils down because I want to talk to you a minute. An outlier. Have you ever felt like an outcast in a group? What is an outcast?
Someone that people don't want in that group.
Yes, it's the person that people don't want in that group. So do you feel like you fit? No. You feel like you don't fit in, okay? Now, you may have never felt like an outcast before, but many of us have felt like an outcast before, okay? An outcast just doesn't fit with that group, okay? An outlier is the same way. It's a number that just doesn't fit with that group, okay? It can either be way low or way high, but it just doesn't fit, okay? So, an outlier skews the data, which makes the data not accurate, okay? What does skew mean? What does the word skew mean? Nobody knows what the word skew means. To mess it up, yes. It messes it up. It makes it lean one way or the other. It makes the measure of center off just a little bit. So we are going to, I gave you a data set, okay? Because we are going to calculate the mean, median, and mode, and we're actually going to do the range too, because it does affect that. We're going to take this data set, and we're going to figure out what the outlier is, and does it affect our measures of center, okay? So the first step, always, every time we do anything, is this. Put the data in order from least to greatest. I want you to do that on your paper right here. Least to greatest. All right, how many people are still working? All right, on your iPad, on your device, whatever you have, I want you to pull up your calculator, okay? I want you to pull up your calculator. If you're having an issue pulling up a calculator, raise your hand. I'll be glad to can help you. All right, I am going to tell you, we are going to use a calculator for this, but here's the thing. On the South Carolina Ready Assessment at the very end of the year, you do have a calculator portion and a non-calculator portion, okay? Every year, my students tell me, I sure wish I'd have had a calculator for the non-calculator portion. I didn't really need a calculator for the no calculator portion. For the calculator portion. So my philosophy has been, you need to be able to do it with or without a calculator, okay? Being able to add up numbers is not a skill that is a 6th grade skill, okay? Being able to divide numbers is a 6th grade skill, and we've already done that a lot this year, okay? So we're gonna, if we do this by hand, it's gonna take us a long time, okay? And what we're doing here is we're trying to decide how this outlier affects the data. So that's the focus of our lesson, not adding, not dividing, okay? So when we add in a calculator, there are some things that I want you to do, all right? The very first thing that I want you to do, when we're calculating the mean, the first thing you've got to figure out is what the sum is, okay? So over here to the side, I want you to write sum equals, because we're going to add up all those numbers. And I want you to write that number down, okay? Now, I want everybody to add these numbers up in your calculator, write your number down. Now, I want you to do the same thing again. I want you to add up all these numbers again, and I want you to see if you get the same thing. You could have made a mistake. I could have made a mistake. Please make sure that you clear your calculator out before you start, or your data will not be the same number. Now we've got to, how many people got 606? Okay. Now we've got to divide by our number of numbers. I want you to write that down. I want you to write the division sign. Now, let's count our number of numbers. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So we're going to have to do 606 divided by 7 equals. We are only going to go to the tenths place. Okay, that's it, to the tenths place. So let's look at our number. If I'm looking over here and I want to round to the tenths place, what number is in the tenths place? The what?
The 5.
The 5 is in the tenths place. So what am I going to have to look at?
The 7.
The 7. Okay. What's the 7 going to make the 5 do?
Go up.
Go up. So what's my answer? 86 and 6/10. That 5 is going to change to a 6. So it's 85 and 6/10. The mean is the what?
The middle.
The middle. So we're going to have to tick off lowest number, highest number, lowest number, highest number, lowest number, highest number, and what are we left with? 95. Mode means what?
The one that's there the most.
Mode means
The one that's there the most.
most often, the one that's there the most often. Do I have a number that is there more often than any other number?
No.
No. So I don't have one. So I'm going to put none because I don't have one. Please don't go on to the bottom part, please. Please. Range. What is the range?
The distance between the largest number and the smallest number.
The distance between the largest number and the smallest number. What's the largest number? What's the smallest number? 32. Now, I want you to go over here to your calculator, and how many times should you do it? 2. And what do you get? 68. Now let's say that these are your test scores for math. What do you notice about these test scores? What do you notice? There's something that sticks out. What sticks out? So y'all are cool with all those test scores. They are consistent. That person's score is consistent on tests. No, what's wrong with it? 32. Does 32 fit? No. All the other scores are what? 90 and above. Between 90 and 100. And then we've got a 32. So do you think this person may have had a bad day, may have been sick, may have had some family drama going on the day that they made a 32?
Yeah.
Yes, I think that maybe they did. So let's say that this person has a really nice teacher, and the teacher says, let's get rid of the 32 because that 32 is an atypical score for you, okay? That is obviously, that's not normally what you make. So our outlier is 32. It just doesn't fit, okay? It's an outcast. It doesn't fit in with the rest. So now we're going to rewrite our numbers down here without the 32. So we've got 90, 93, 95, 97, 99, and 100. So what do we need to do to calculate the mean? Add them all up.
And then divide how many numbers?
How many numbers do we have?
6.
6. This time we have 6. I want you to do both of those steps and see what you get. Could we have taken 606 and subtracted 32 since we took out 32? Yep, we could have. So whichever way you did it is fine. but you should have gotten 576. 576 divided by 6 is 95 with a 6 that keeps on going, okay? So if I round it to the 10th place, what do we get?
95 and 7/10.
95 and 7/10. So look at me. Look right up here. This person's test average went from an 86.6 to a 95.7. Did their test average change? Yes. That 32 brought them down an entire letter grade, okay? Almost 10 points, all right? It was 9-point difference. Is that a lot? Did that one bad grade mess up their average? No.
Yes.
Yeah, it did. All right, now let's look. Let's see what the median is. So let's mark off low, high, low, high, and I'm left with what? How many numbers in the middle? 2. So we've got to find the average of those two. So add them up and divide by 2. So 95 plus 97 divided by 2. How many people got 96? What you should have gotten, 96 is halfway between 95 and 97. Okay. What's the mode? What number is there most often? None. And the range, our highest number is 100. Our lowest number is what? 90. So what's the range? 10. So we went from 68 from top to bottom to 10 from top to bottom. Is that a big difference? Yeah, that is. So let's look. I gave you 2 questions. How does the outlier affect the data? Or how does removing the outlier affect the data? So what happens when we have that outlier in our data?
It brings up the average.
When we have the outlier in it, what happens? So bring it up,
It brings it down.
brings it down. So the outlier brings down the measures of center. Meaning and median. It brings both of them down. The mean and the median both came down. Is our data more accurate without the outlier? Yeah. This kid doesn't typically make a 32. So our data is more accurate without the outlier. Thank goodness people sit at these tables because I went like this and the whole thing went. Kids were like catching it. All right. We have another set that we're going to write over on the left side. Okay, so I want you to copy these numbers down. On the left, 102, 78, 114, 96, 96, and 102. So what's our first step? Put them in order. That's always the first step. Put them in order. Oh goodness, that will not work. All right, so we're going to do two things. We're going to calculate the mean, median, mode, and range of these numbers, okay? Then we're going to pick out the outlier. Then we're going to calculate it all again without the outlier. And we're going to talk about what it means, okay? So, when we do the mean, the first thing that we're going to do is we're going to add up all the numbers. And how many numbers do we have?
6.
I want you to do that. Okay. I just want to make sure you know your numbers. I know. All right, what'd you get for the mean?
98.
98. How many people got 98? Yay, look at y'all go. All right, median, what are we going to do for the median?
Which one's in the middle? You're gonna start crossing them out.
Low, high, and what do we have in the middle? So what are you going to have to do?
Add them together and then divide by
Add them together and divide by
2.
2. All right, go. All right, what do you get?
99.
99. Mode means what?
Which ones are the most?
Which ones are there the most?
We have 2.
We have 2. What are they?
96 and 102.
So we have to list both of them. 96 and 102. We've got to list both. And the range, what are we going to do?
Add them together.
No.
So
The highest one minus the lowest one. Highest one minus the lowest one. So what do you get?
36.
36. Let's say that these are the high temperatures for a week in Phoenix in August. Is there an outlier?
Yes, and 2.
No.
78.
This side. 78. Yes. You're on the wrong side, Caleb.
Because,
The outlier is 78.
because everything's 90 or above.
Everything else is 90 or above. So now what do we have to do? Figure it all out without the outlier. So how many numbers do we have? If we take this one out, how many do we have? 5. So figure out the mean without the outlier. How many people got 510? Did I do something wrong? So what's your average? What's your mean? It's what? 102. Your average is 102. Now we've got to look at these numbers. 96, 96, 102, 102, and 114. So let's mark, I'm going to rewrite my numbers just to make it a little bit easier. And we're going to mark off low, high, and what's in the middle?
102.
102. Mode means what?
The one that's there the most.
The one that's there the most.
It's going to be the same effect then.
So it's going to be 96 and 102. And what's our range this time? 18. Did the outlier affect this data? Yeah, it did. Was it as much of an effect as it was over here? No.
It's still
But
affected
it did change our data, okay? This outlier was not as significant as the first outlier. It wasn't a big difference. But if you look at our range was taken in half, okay? Our range was divided in half. So it did skew our data, all right?